Okay, we're going to move into section 10.3, and in this section we're going to learn how to multiply radicals. In the previous section we actually saw situations where we multiply radicals, but what was challenging was I think we had something like the cubed root of x squared or something like that, and the fourth root of x. We did a multiplication of radicals at that time, but the thing that was challenging was that the two indices were different. And so our strategy at that time in section 10.2 was to convert these to their fractional exponent form and then use that. It turns out that under the conditions where the radicals are the same, it's actually pretty simple. If I have the same radical, same index, I basically keep that radical and I multiply my two radicands together and they become the radicand of the new radical statement. So it's basically saying you can put two radicals together into one radical if the indices are the same. Now, of course, the reason why this is true happens to deal with the exponential rules. If we rewrite this as a to the 1 over n and b to the 1 over n, all right, and this side to ab to the 1 over n, then you can see all we're basically doing is using that power of a product rule is in play here. So the power of the product basically says we can distribute that power. So we get a to the 1 over n and we get b to the 1 over n. So basically this follows because of our exponential rule. And it's very easy to use as long as the indices are the same. So looking at some examples, the first one we have the square root of 5 times the square root of 7. So the radicals are the same. They're both indices of 2. So we're going to keep that radical and multiply my radicands. Of course, performing that multiplication, we end up in that case of the square root of 35 as our final answer. So everything is good. So that's how easy it is. The next one, we have two cubed roots. We're multiplying them, so we're going to keep that cubed root and multiply my two radicands. Unlike this example where I can perform the multiplication, I can't really perform the multiplication here because we don't know what x is. So this is as far as we can take that. We can't even simplify it anymore, as you'll see in a moment. Trying to make this hard, what if we have three of them? Well, we're multiplying three radicals. They all have the same index. So we're basically going to keep that index and we're going to multiply all of our radicands together. This can be 45x, and there would be our answer, the fourth root of 45x. So again, relatively easy if we have the same index. If we don't have the same index, then it becomes hard and we need to use other things we've learned before. Continuing on, the square root of 10x times the square root of 3x. Well, again, we have the same radical, so I'm going to keep that radical and take 10x and multiply it to 3x. And as we learned back in chapter 4, we just multiply numbers to numbers, and x times x is x squared. So that becomes the square root of 30x squared. Looking ahead into where we're at, notice that I can simplify this right now because the index is 2 and my power is 2. So basically these two things will go away. So a more simplified answer here will be the square root of 30 times x. And again, we're going to assume that all of our our variables, let's just make sure they're nice and positive so we can use that. So there's just kind of a hint of what's coming. The next one, again, fifth root times a fifth root. So I'm going to keep that fifth root and multiply a monomial to another monomial. And that becomes 8x to the fourth, and we have the fifth root. So again, nothing can be simplified here because my power is less than the index, and we're good to go. Trying to get this a little harder, we got the cubed root of x plus 1 times the cubed root of x plus 1. So I'm going to keep that and multiply my radicand to my radicand. And that's basically x plus 1 squared and the cubed root of x plus 1 squared. So again, pretty easy. Next example, letter G, we have a square root of x minus 2 times the square root of x minus 2. So this becomes the square root of x minus 2 times x minus 2, which is the square root of x minus 2, right, squared. And again, assuming everything's positive, right, that just simplifies to x minus 2. Of course, back in 10.1 we put an absolute value, but we'll just assume everything's nice and positive and we're not going to worry too much about stuff. So there we go. So that one actually could be simplified because the power and the index are the same. So let me remind you, I should have reminded you earlier, I'm basically using that, right? When my power and my index match each other, then we can wipe the radical clean. So I did it here with the x squared, and I did it here with the x minus 2 squared. All right. Next one, we have a fifth root times a fifth root. So I'm going to keep that fifth root and multiply my two fractions. Of course, how do we multiply fractions? Tops to tops, bottoms to bottoms, and that's about as far as we can take it. We're going to learn later on, let me put a little asterisk on this. There's more we can actually do with that. But for what we're learning right now, since we're just learning how to multiply radicals, right, that's where I'll end it. So again, the idea, pretty simple. If my radicals have the same index, we just keep it and multiply my radicands. Finish as far as you can go, simplify if need to, and that's actually where we're going to be heading next. We're going to be, since we've seen some simplification, we're going to do more with that coming up, and that'll be in the next video.